I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 29th. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see the beginnings of a gale starting to form in the deep South Central Pacific with seas to 31 foot, and this is expected to bloom as it lifts to the northeast, providing hope for surf in the future. Let's get into the details. So given that the North Pacific is pretty much asleep now, we're going to start focusing on the southern hemi. And as usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a trough. That would be a push in the jet to the north. And that would help form a clockwise circulation. Remember, this is the southern hemi, and low pressure in the southern hemisphere rotates clockwise, and that also, in the upper atmosphere, circulates down the lower levels of the atmosphere. And low pressure, of course, if it's strong enough, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So we're looking for a trough. Right now, we have a ridge right here under New Zealand. The jet is pushing south, but then it almost looks like the start of a trough starting to form here, just we'll call it southeast of New Zealand. And also bear in mind that the ice line is very far to the south this time of year. Winter has not really started in the southern hemisphere, so the ice line, when we get into the wave models, you'll see it, but it's down below 70 south, so there's plenty of space here to support the formation of gales and for winds, even in the very deep South Pacific Ocean, to get traction on the ocean surface. Of course, if there's ice there, wind can't get any purchase, and you can't generate any swell. All right, so put this into motion. As you see, this isn't a particularly impressive trough as we get into Sunday night, but maybe building a little bit as we get into Monday right here, being supported by 130 knot winds lifting to the north. That would get you a little bit of a circulation going right there. That is exactly where we expect the core of this developing gale to be, and we'll get into that in other charts in a minute. But as you see, we get into Tuesday. Trough continues pretty good. The Southern California cutoff line's about 117 west, so basically right there. So good amount of area, and it's really the western half, half of the trough where the winds are pushing to the north. That's what really matters. So not too bad a position, but then as we get into Wednesday, that starts fading out. Then beyond, we're looking for anything with, we'll say, 110, 120 knot winds, and pushing to the north. We're not seeing anything as we get into Friday and Saturday. Now, by late Saturday, the jet generally starts lifting to the northeast, and maybe, I'm looking for anything here that might look like a legitimate trough. We're not really seeing it, but maybe as we get later into Sunday, a week from now, there'll be some more hope. All right, let's go take a look down at the surface models, see what they have to say. Here we are, surface level pressure, surface level winds. All right, here is our low. You can see it right there. It was a 960, probably a 958 millibar low. So that's pretty deep. Winds, 40 knots as of 18Z Sunday. Building to 45 knots as of right about now. And forecasts lifting, look at this, aimed well to the north as we get into Sunday night and even into Monday morning at 40 to 45 knots. So taking a track along this line here, which is exactly what you want to see. Continuing into Monday morning, still starting to fade, a little core there, a little dot of 45 knot winds, another one there. But generally a broad area, 30 to 35 knot fetch. That's probably generating 13, that could generate 13 or 14 second period swell. Also notice a new developing fetch building supposedly on Monday night as the initial fetch moves out of the California swell window. There's that 117 west line again. And this new one starts building with 40 knot winds again, aimed pretty well off to the northeast, building to 45 knots midday on Tuesday into Tuesday night. 50 knots over a small area late Tuesday night, and then fading out, moving out of the swell window, and that's the end of that. But it looks like two potential areas to support swell development. That's not too bad. Then we go out into the week. We know the jet stream kinds of falls apart. We're not expecting to see much. There's some 35 knot fetch on Friday night. Oh, building a little bit into the 45 knot range. So this is kind of new on the charts. See what this does. And, actually, not looking too bad. Maybe an improving pattern. At least look, and 55 knot fetch, supposedly a week from now in the South Central Pacific. Hey, and continuing. Now, do we believe the models? Absolutely not. It's like the storm or the gale that's forming right now at one point was supposed to have 53-foot seas with it. That just disappeared from the charts. We're much more moderate now. So this is probably, again, a gross overstatement of what is going to happen. 55 knot winds aimed to the north for 24 hours or so. But whatever. We'll take anything we can get. All right, let's go take a look at the wave models. So we're going back in time. We're going back to Monday, almost a week ago, 6 days ago. A little gale formed, again, in the Southeast Pacific. That seems to be the call this year, and that's kind of typical of what we would call La Nina years. So officially, this is not a La Nina year, but by all objective data, that appears to be what it is. As you see into Monday night, this gale starts building, or started building. This was Monday a week ago with 28-foot seas building up to 31-foot seas to 33-foot seas right there. Max seas over this whole domain right there at 51.5 south, 117 west, right on the hairy edge of the Southern California swell window. And then it started fading while lifting northeast and out of the picture. We'll run through this for the rest of the week. Now, there was this gale down here with 29-foot seas. We're not certain that any swell is necessarily going to evolve from that because, watch this, it goes pretty much from west to east and doesn't lift to the north at all. So probably no swell to come from that. We'll roll this on out from there. We're into Saturday. This is 24 hours ago. And then here's the beginning of our gale, and there we are, current time right now. All right, let's go take a look at the wave models looking forward. All right, 18DC Sunday, bye. Tonight, supposedly, 36-foot seas over a decent-sized area, lifting northeast, building to 37 feet Monday morning, and that's about the peak of it right there. It looks like 37-foot seas. Not bad. Unshadowed from Tahiti relative to California. Swell for Hawaii? Probably not. We'll just go back. So Hawaii is at we'll say 158, and this system starts at about 154 west and is tracking northeast, so probably not even any sideband swell for the Hawaiian Islands. Anyway, we get into Monday. The system starts fading, seas down to, what is that, about 34, 35 feet on Monday night. But then the secondary system starts organizing. It too, not as strong as it was on earlier runs of the model. 35-foot seas over a small area. Oh, they are building to 38 feet, 30, 32, 34, 36. I'd say 37 feet. 38 seems over maybe one tiny pixel on the image. That's not enough to get meaningful swell, but okay. We'll say 37-foot seas. So secondary pulse of swell, again, from a pretty south angle relative to California. That's great for Southern California, not so much for Northern California. And then fading out. Now let's see what the models say as we go out in time. We know there's a dead spot, and then there's this little gale we saw that forms supposedly almost a week from now. You see 28-foot seas over a tiny area. Doesn't do much. And then that other system, the stronger system, was supposedly 40, that's not, that's up there, 43-foot seas, 14, that's what, not here, so, okay, take this out one more click, there we go, 40, almost 41-foot seas, and let's see if we can get, no, that's about it, 40-foot seas over a small area, so it kind of seems like we're on the cadence for about once every 6 days, we get some sort of swell, something like that, so not so bad. So we know there's swell in the water that's going to hit this week from a previous gale here in the Southeast Pacific. Then this new one forming, what was that, Monday, Tuesday sort of thing. And then another swell or another gale behind that, again on a Sunday, Monday, so about every 6 day cadence. That wouldn't be too bad. We'll take whatever we can get. And then looking at the North Pacific. So it's not completely asleep. There's this little gale, 18Z Sunday, formed in the Gulf of Alaska. Oh, what is that, 17-foot seas? Yeah, about 17 feet. It's basically wind swell and forecast to build to 18 feet, maybe even 20 feet. But this is pretty much out of the swell window for San Francisco, more up into Northern California. But still, so the cutoff is pretty much like if you're right here, anything over on this side of the intersection was at 50 north and 140 west. So let's see. Yeah, we got like right there, 18-foot seas in the swell window for the San Francisco area. So wind swell to result. And then we'll roll this out because there's actually another system forecast here relative to Hawaii, 19-foot seas. This is on Thursday, Friday, and then building to 25 foot over a very small area, but only, what was that, 900 nautical miles northwest of the Hawaiian Islands. So maybe some 13, 14 second period swell with decent size possible for the Hawaiian Islands. And then yet another, and look at it, it's actually still going on. And then another tiny gale on Saturday pushing towards Pacific Northwest. But it's this guy here with what, 26-foot seas tracking through the northwestern Gulf down to 21-foot seas, 180 hours out. Now, we don't believe any of that. Probably the one targeting Hawaii is the most believable, but there's still something to monitor here in the North Pacific. So maybe a little bit of combo swell with luck, both coming from the south and the northwest, but all that is projections by the models. There's not wind blowing on the ocean surface, and until that happens, you can't have seas, and therefore you can't have swell. It's all just a imaginary figment in the computer's mind, other than the building fetch down in the southern hemi right at this moment in time. All right, let's go take a look for wind swell. Here we are, surface level pressure, surface level winds. Again, here's the Gulf of Alaska system, 30-knot northwest winds, generating what we know will be wind swell for California. Otherwise, strong high pressure, 1028 millibars. 1032, 1034, that's strong. We'll call this moderate high pressure, but it's pretty solid in coverage, making those standard trades pushing into the Hawaiian Islands at 15, maybe 20 knots in patches. On Sunday, that basic pattern continues as we get into Monday. Actually, trades weakening a little bit, but that fetch pushing into the Pacific Northwest, generating wind swell pushing down into California. I think it's on Tuesday that it arrives, later on Tuesday. And then trades continue for the Hawaiian Islands, but not really impacting the islands. Most of the fetch is a little bit off to the east, so that makes for cleaner conditions there. High pressure continuing. Starts building for California along the north and central California coast. Is that typical summertime pressure gradient sort of thing. You get high pressure here, low pressure inland, not a heat low, but some low pressure inland, and then you get winds building here along the California coast. That makes wind swell, but also a pretty choppy, ugly mess as well. So 20, 25 knot north winds. So we get midweek into the end of the week. Little low pressure pushing into Oregon on Friday. Maybe that'll cut out a little bit of the high. But here's the next high pressure building in. Also notice here's that fetch relative to Hawaii from the, we'll call it a cutoff low. And then new low pressure systems starting to build into the Gulf. So interesting sort of mixed up pattern here. But at least that suggests there could be hope for surf. You can just look at it here. 180 hours out. North winds for the Hawaiian Islands. Actually, let's go back and take a look at that. Yeah, oh my, I didn't quite see that. So starting Friday, there we go. You can see this high pressure here, low pressure here. By Friday, maybe not till Saturday, till north winds really start blowing. Not hard, just like 5-10 knots, but that kind of puts a pretty ugly lump on everything relative to the northern shores of the Hawaiian Islands, and that's supposed to continue into Sunday, yes, and maybe, if anything, only getting worse. All right, so that's the wind swell pattern. Let's go take a look at precipitation for California. So Sunday afternoon, early evening, scattered precipitation over higher elevations of the Sierra. is projected, but fading out as we get into Sunday night. Another low pushing into the coast, as we saw there. Maybe chance for rain, not even to San Francisco, and nothing from that. And then we're just looking for anything in this area, and it there we go, maybe a little drop for Tahoe Friday. Yeah, Friday night, something like that, almost a week from now. And then, again, it's starting to look like that line setting up where all the precipitation is from the Northern California, Oregon line northward. Not that it makes a whole lot of difference. All major resorts are shut down, and probably for the season based on the latest projections of what's going on with the spread of COVID. So kind of write that off. But backcountry, if you have the skills and you have the equipment, there is plenty of opportunity. Snow forecast for Squaw Valley for the next weeks. This actually goes out 10 days, so we'll chop it off around here. We'll say, 7 inches. Snow line, okay, here's the bottom of Squaw. The red is above freezing temperatures. The gray is sort of sleet. The white is actual snow. So, snow line, generally for the next couple of days at about, we'll say, 7,000 feet. And then towards next weekend and beyond, the whole way to the top. This is the top of Squaw at like 9,000 feet. So certainly an indication that spring is coming. Wind, not exactly calm over the peaks either. Peak elevation gusts into the 60, almost 70 miles an hour. I think that's knots actually. And the same thing at different periods. So kind of windy. Kirkwood, not even that generous. We'll give it 2 to 3 inches maybe. Same profile. They are higher, so whatever snow you get probably will stick. And then up at the top of Kirkwood at 10,000 feet, sure. But even as you get into about 10 days from now, it'll be above freezing even to the top. Wind issues, maybe not quite as bad, but still nothing perfect. Then Mammoth, no appreciable snow. Snow levels, you can see for yourself. Wind levels, nothing to get excited about. All right, let's go take a look long-term. What's going on with the Madden-Julian Oscillation, and of course, El Nino or La Nina. First up, let's take a look and see if we can find any evidence of the active phase of the MJO over the Pacific Ocean. This is the East Pacific here. This is the West Pacific. This is the equator. This is the dateline right here. The arrows are what we're looking at. They are 5-day average winds. Data obtained from a series of buoys, the TAO buoy array, strung across the equator, used for monitoring El Nino, but you can get a pretty good idea what's going on if you're in the active or inactive phase of the MJO. And of course, the inactive phase basically sort of supports high pressure over both the North and the South Pacific Ocean. It therefore stealing energy away from the jet stream is not really supportive of storm development. The correlation between the MJO is strongest in the Northern Hemisphere in winter months, but still it has some correlation, or it can feed, if in the active phase of the MJO, it can feed energy into the jet stream in the Southern Hemisphere during winter months down there as well. All right, so wind solidly from the east over the East Equatorial Pacific, continuing over the Central Pacific, and on into what we call the Kelvin wave generation area, that area from 135 east to 170 west, 5 degrees north and south of the equator, basically fancy words for the West Pacific Ocean. That's where the MJO has its biggest impact, one, in terms of feeding energy to the jet during the active phase of the MJO, and two, generating Kelvin waves, a key component of trying to drive the formation of El Nino. All right, it is anomalies. So the winds are blowing pretty strong for the east, but is it harder from the east than normal or weaker? Well, anomalies are the way to compute that. This basically, the model takes into account what the average winds normally are over the Pacific Ocean. And if they're stronger than normal, then you get a little arrow like this. And so they're stronger out of the east than normal. But if they're weaker than normal, the arrows disappear. But clearly, in the Kelvin wave generation arrow, We still have arrows. They're still pointed out of the east, and they're still pretty decent size. So what all this says in a nutshell, it sure looks like we're in the inactive phase of the MJO, at least for now. So what is the forecast for the next week? All right, this is zonal wind anomalies right there. Fancy words for are the winds stronger from the east or stronger from the west? Okay, the yellows and oranges are stronger from the west, the blues stronger from the east. We want to see west anomalies. That's the hallmark of the active phase of the MJO. Here's where we are today. That's March 29th. This is the whole planet on one chart. The Kelvin wave generation area, the West Pacific, starts here and goes to about here. Pacific Ocean in total starts here and goes the whole way over to about here. Then over here, you're into the Atlantic, and over in here, you're into the Indian Ocean. All right, so it's from here to about here that we're interested in. So right here, big, fat, clear indicator of the inactive phase of the MJO. This is back in last week, 5 days ago. Strong active phase of the MJO, easterly anomalies. Here's where we are today. What's the forecast? Well, weak west anomalies forecast in half the Kelvin wave generation area for the next 7 days. Developing, actually, not until probably till about April 2nd or 3rd. And east anomalies still hanging over the date line. So pretty much a very mixed pattern in favor of the inactive phase of the MJO. So no clear support for storm development. But we just looked at the other models that there are some storms forecast. So the MJO does not preclude storms from forming, but if you were a gambling person, when you see these sorts of things, you go, odds are probably not good support for storm development. Whereas when you see more of this reddish pattern, then you go, well, that's a little bit more support for storm development. Now, did we have a whole lot of surf in late February and early March? Well, not a whole lot. So, there is no strong active signal indicated for the past month or 3 weeks or whatever this is, February 28th. Yeah, so the past month. And the next week forecast, if anything, suggests inactive phase. So no clear support there either. So let's go out a little bit further. Here's a 2-week view. This is outgoing long wave radiation, classic MJO sort of looking data. So this is precipitation. That is, so a way you can measure precipitation without actually looking for it is sunlight reflectivity off the ocean surface. If you have a lot of sunlight bouncing off the ocean surface, that would assume one to say there's high pressure, meaning the inactive phase of the MJO, like right there. So there's South America, Central America. The equator runs right along there, right? Kelvin wave generation area right here in the West Pacific. But we see the active phase in we'll call this the Eastern Indian Ocean and over the maritime continent. There's Bali and Java, and the Mentawai's all strung along there. All right, so that's today's picture. 5 days from now, inactive phase of the MJO supposedly moving out, and the active phase starting to move into the West Pacific. And here's the good news. By about a week and a half from now, the active phase of the MJO is supposed to be filling the Kelvin wave generation area, feeding energy into the jet stream, and continuing at the end of the model run 2 weeks out. So that's pretty good. That's what the statistic model says. Now, the dynamic model says pretty much the same thing, but the active phase, instead of staying strong, you can see it here, instead of staying strong and pushing into the West Pacific, it basically withers and is just a very weak active phase. So this is this kind of deal where when you're in La Nina, the inactive phase of the MJO is strong, the active phase of the MJO is weak, and that's kind of what we're seeing here, where the statistic model doesn't really sense that as well. All right, let's dig a little deeper. So a little bit more discussion here around MJO positioning. Phase diagram charts, nice way to see where the active phase is and how strong it is. So how do you read this chart? Assume you're looking down on the North Pole, and the equator runs around the outside of the chart, and the MJO moves from west to east, from the Indian Ocean over the maritime continent, over the West Pacific, over the East Pacific, under the United States on the equator, across the Atlantic, over North Africa, back to the Indian Ocean. Okay, so wherever the active phase is, in this case it's where the heavy dot is, so in the, we'll call that the Western Maritime Continent, the inactive phase is pretty much on the opposite side, so somewhere over in the Eastern Pacific, so off California coast right now. Okay, the further the dot is away from the circle, the stronger it is, so we'll call that a modest active phase of the MJ over the Maritime Continent, and forecast over the next 2 weeks to track roughly into the West Pacific and probably pretty weak. That's per the statistic model. The dynamic model saying, yes, it's the active phase is to track to the east, but even weaker still and just crashing right down around the center and be so weak as to probably not even be noticeable in the West Pacific when it gets there. Not a good sign. Then here's the upper level model used mainly for tracking precipitation, right? Okay, and this is a statistic model. So the oranges and reds are areas not favorable for precipitation. We'll call that the inactive phase, and they run about a week ahead of what's going on at the surface. The greens, favorable for precipitation. Generally speaking, the active phase, the MJO. So there's South America, Central America, New Guinea. The equator runs right along the middle here. So we could say the inactive phase moving to the east, pushing into the Atlantic today, with the active phase starting to build in the West Pacific, and the active phase makes its trek across the Pacific and into Central America into about, maybe the 20th of April or so, and about that same time, the inactive phase starts building. So if there was a shot for any storm or swell production, it's in this window from, we'll say now, till about mid to late April. Then the inactive phase comes in, pretty much shuts everything down the whole month of April, and it's not till we get to the end of the model on May 6th that we start to see the active phase of the MJO starting to materialize again in the West Pacific. We'll go a little further, the 1 month CFS model. You can see right up here. So it's 850 millibar wind anomalies. Again, the east or west component of the wind is up about at 850 millibars, about 4,700 feet up. So here is the dotted contour is the inactive phase of the MJO. Oh, Kelvin wave generation area from here to about here. You see, and here's where we are today. So the inactive phase is pretty much out of the Kelvin wave generation area. East anomalies, east of the date line, and supposedly, according to this model, westerly anomalies and the active phase of the MJO building and holding into about, about April 15th, something like that, and then fading out with the next inactive phase, the dotted contour, moving into the west Kelvin wave generation area, we'll say mid to late April and continuing into the latter part of April. All right, and let's go yet one further. This is the 3-month CFS model, going out 3 months. We don't even believe a model out a week, much less 3 months, but it's still good to sort of tease us, try to get some sense of what's going on. All right, this model is whole planet on one chart again. Kelvin wave generation area starting there, going to about there, the whole way up the chart. But this is past performance down here, and this is the forecast up here. Now we see two strong westerly, the yellows and the reds are westerly anomalies, the active phase of the MJO, one back in February, another back in January. It was January when we had all our winter surf, all of it condensed into 1 month, and then that was pretty much it. Right now, there's where we are today. East anomalies fading in the Kelvin wave generation area, and looking up, it looks like westerly anomalies pretty much non-stop, with maybe some little windows for east anomalies in the inactive phase of the MJO to set up. Let's overlay the MJO. Now here is the real striking pattern. This is a very weak MJO pattern. Here was our last, what we'll call semi-strong MJO, 3 contour lines. Now we have a 1 contour line inactive phase of the MJO that's in control. Westerly anomalies forecast building, but very, very weak. And then we go to an active phase. The solid contour is the active phase of the MJO in the we'll say early April time frame to latter part of April. Then this very weak mixed bag kind of pattern with, again, another kind of weak inactive phase, another weak active phase. I mean, basically, the MJO looks to be asleep. Yes, it's going through the movements of being active and inactive, but each particular occurrence is very weak. They're kind of thin. They don't last long. They don't have a lot of heft to them. And it just kind of looks like the atmosphere is asleep, much like what we talked about last week. Just no momentum in the atmosphere, nothing to really get things going. And even all the other data sort of suggests this kind of pattern in the ocean where we're not into La Nina, we're not into El Nino, we're just somewhere in between and just muddling along. All right, let's overlay the low-pass filter here, and that helps explain some of it. So so what is this? The solid contour is, and notice it's right over the Kelvin wave generation area. It's like a low-pressure bias, right? And one would think, okay, well, that's supportive of El Nino, but notice the last of the second contour is fading today. We go into this even weaker pattern where it's just a single contour. Now, we'll take this. It's better than having high pressure over the Kelvin wave generation area because that is certainly a La Nina sign. And notice the dotted contour here, this is high pressure. This is what has been locking down the Indian Ocean for since mid last summer. All the fires and the really dry pattern over there, driven by high pressure in the Indian Ocean. That looks like it's supposed to fade as we get into May. And the good news is the low pressure bias doesn't dissipate over the date line in the Kelvin wave generation area, but you notice it is definitely retrograding to the west, and west anomalies are retrograding to the west over time. This is 3 months out. Maybe suggesting that at some point this whole thing is going to collapse sometime later this summer in the Pacific, and in fact, maybe we will head towards some sort of a La Nina pattern, but that's very much a guess and a reach at this point in time. All right, so let's go start looking at the ocean. Let's see if we can get some sort of sense what's going on there in regards to El Nino, La Nina. Enough of the MJO. All right, so more data from the TAO buoy array. This is the West Pacific here. This is the East Pacific here. These are the anchor lines on the TAO buoys on the equator, and the X's are the sensors on those anchor lines. They collect data. They are wired to the buoy. The buoy has a panel on it that sends the data via satellite up, and then all the data from all these sensors gets loaded down to somewhere over in the Northeast Maryland, something like that, into a central computer system. They throw a model on it and use to fill in the gaps, and you get this image that sort of gives you a hint of what the subsurface temperature profile looks like in the ocean. And what do you want that for? Well, you can use it to monitor Kelvin waves moving from west to east across the Pacific. So we have 30 degrees centigrade, that centigrade water temperature in the far west Pacific. They've actually retrograded. I think they were over at 165 east last week, so they're retracting. The 29 degree isotherm line was at 180 or even 178 last week. It's retrograding. The 28 degree isotherm made a little push here to 150 on the surface, but it's pretty much holding where it's been. Maybe pushed eastward a degree or two. And then the 24 degree isotherm line pushing into Ecuador. So not really a whole lot of change from last week, but the point being, there's still a fair amount of warm water here in the East Pacific, so no clear signs at all of La Nina, hinting weakly at El Nino, but weakly is the operative word here. Now, it is the differences from normal for this time of year, anomalies. All right, so what do we have? We have this, it actually is a Kelvin wave. There is a Kelvin wave here. It's warm water from the westerly wind bursts associated with the active phase of the MJO in January and February, pushing 1 degree centigrade above normal, 2 degrees centigrade. The leading edge of the Kelvin wave is just starting to reach Ecuador now, but behind it this is like 3.5 months of warm water still pushing this direction. So there is Warm water in the supply chain. There is no obvious source of cold water. There is no obvious La Nina pattern setting up right now. But this all looks generally pretty weak. I mean, we'll take it. It's better than nothing, but it's basically warm, a little bit above warmer, and holding that way, but not some big, strong push of warm water. Let's take a look at another model. Now, this model suggests the leading edge of the Kelvin wave is at, what is that, about 105 west, something like that, so south of Mexico somewhere, with the leading edge of it having 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 4, a little pocket of 4+ degree anomalies embedded in it. That's a pretty warm Kelvin wave. You can see, even here, the whole way back into, the maritime continent, there's warm water flowing off to the east. Here's the upwelling phase of the Kelvin wave cycle. When you get a Kelvin wave and it washes in, you get this little burst of cool water that pushes up, and then another Kelvin wave. This is probably our final Kelvin wave number 6, poised to push into Ecuador. And that would be, so 3 months from now, where are we at here? We'll say April, May, June, into about the end of June, and then after that, I doubt there's enough energy in the atmosphere to create another solid active phase of the MJO, which would in turn then create another Kelvin wave. So this might be the last in the cycle. Upper ocean heat anomalies. So this is basically like the chart we saw above, but putting it in time. Here's time down this axis, West Pacific here, East Pacific here. You literally can see Kelvin waves over time pushing from west to east. This is what, Kelvin wave number 3, or I think it was number 4. 2 stalled Kelvin waves. This was last summer. We thought we were getting El Nino with cool water developing in the East Pacific. No, we got another active phase of the MJO, produced a Kelvin wave in, we'll say late August, early September. That pushed the whole way across the Pacific Ocean, finally dried up, finished its thing off in almost the January time frame. And then we got another, this sort of January, February. Actually, what's that? No, it's December. Okay, but there's the January, February push, so that'd be the second half, creating yet another Kelvin wave. This Kelvin wave number 6. It is its leading edge right there at like 115 west, according to this. And there's the upwelling phase of the Kelvin wave cycle. We don't know. We assume this one has enough momentum to push it into Ecuador. But then you see this sort of the cool water starting to encroach to the east, suggesting, and you see general cool waters hanging off here, suggests that maybe this is the end of the Kelvin wave cycle for a little bit. Sea level anomalies. All right, so what's this chart about? It's just the height of the ocean. Very sensitive data from the Jason 3 satellite data. Strip out the wind, strip out the wind waves, strip out the tide. We're looking for a bump on the ocean surface. So there's South America, Central America. That's the equator. That's the date line. That's New Guinea there. And we see this little, there used to be this giant area here like a month ago of 5-centimeter anomalies on the equator. And so warm water at depth expands, and when it expands, it pushes the water above it up, creates a little bump on the ocean surface. Well, this is the last of the Kelvin wave bump here, and it's 0 to 5 centimeters over a pretty small area from 140 west to about 105 west, so basically south of Baja and mainland Mexico, and it's pushing slowly off, just confirming what we saw in the other charts. There's warm water here, not a lot of it, not real strong, slowly inching towards Peru. All right, sea surface temperatures, all right? We've talked the MJO dynamic, right? We've looked at subsurface temperatures and Kelvin waves. What's the effect of those Kelvin waves and ocean, winds above the ocean, on the ocean surface? What's happening? The interesting part here is we have pretty warm anomalies. So this is Peru here, warm anomalies off of Peru, off of Chile, and then off of Central America, right? And we see this big warm flow. The images are kind of convoluted here, but on the equator here, tracking from off of Central America. I mean, it almost looks like El Nino. But the interesting thing is you see this cold flow Same version of it here coming up off Peru and off of Panama, and basically going right on the equator through the heart of this warm pool, suggesting there's some east anomalies, or maybe it's just suggesting that cool pocket we saw. The upwelling phase of the Kelvin wave cycle is being squeezed out and the cool water is doing its thing, and as soon as that's gone, then we'll return to a warm regime here. Not quite sure, but we also know there are east anomalies stronger than normal in this area, and that could be causing upwelling. So it's probably a combination of both. Inactive phase of the MJO creating east anomalies, cool pocket upwelling phase of the Kelvin wave cycle bleeding cool water to the surface, and you get this sort of little flow. How long will it last? Probably not too long, but we're going to keep our eye on it. Here's the 7-day temperature trend. Now, it's just a trend. It's not actual water temperatures, but the yellows and reds suggest warming. So we have this weak warming pattern off of Peru. There's been this cool pool. It looks like it's falling further south, which is good. But here's that cool, little tongue of water off of Ecuador, and pushing its way off to the east. The interesting part here is just notice this today, little pockets of warming right here. Maybe this is the end of the cool regime. Too early to know, but this tends to be a pretty good leading indicator of what's going to happen a week or 2 or 3 out, suggesting cool water still hanging, but maybe it will be short-lived. And then finally, the overview image here, South America. There's the cool finger. There's the warming off of Peru. So it's sort of this mix of El Nino warm water, but not that warm. La Nina cool water, but not that cool and not that large of an extent. So a mixed pattern. And then you have upwelling off of California and Mexico, upwelling off of Peru, driven by high pressure circulating there and high pressure circulating there. A little bit stronger than normal, but overall it's just this mixed bag. Another thing to consider here. Lots of warm water in the Atlantic, above normal warm water the whole way. So Cape Verde Islands is the Cape Verde storm corridor. Lots of warm temperatures there. Gulf of Mexico cooking. This is warmer or as compared to normal, warmer. So you can see the Gulf Stream. Lots of warm water in here and even out here. And we know that we're not in an El Nino pattern. Shear's reduced over the Atlantic. We talked about this last week. We were expecting a reasonably strong hurricane season for the Atlantic this year, which there's this inverse relationship between the Atlantic and the Pacific. When the Pacific is active in terms of swell production, the Atlantic seems to go asleep. When the Atlantic is awake, the Pacific seems to go asleep. And it looks like it's now going to be the Atlantic's turn as we get into this summer. Actual temperatures in the Nino 1.2 region. This is the area off of Peru and Ecuador. A little bit warmer than normal. Almost half a degree, 0.438 of a degree. They're actually warmer up to 0.8 there for almost the whole month of March, but starting to back off a little bit, or maybe it's just a little dip like it was here. Hard to say. Anyway, Nino 3.4, the index, the official El Nino monitoring region. It's from 120, basically on the equator, south of California out to almost the date line. Today's value, 0.557, so a little bit above half a degree above normal. El Nino, you need 5 consecutive months of half a degree above normal, and we've had 2 weeks of that. That's about it. Otherwise, you see, we are not, and nor have we been, neutral or negative La Nina territory. We've just been slowly simmering, a very light simmer at about 0.35 or 0.4 of a degree above normal. And we've been that way all winter for the most part. But it hasn't seemed to have any significant impact on the jet stream or anything else. All right, Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. What's this all about? Well, okay, we talked about the MJO. Then we went down into the ocean. We looked to see what's going on with temperature profiles below the ocean surface. Then we looked at temperature profiles on the ocean surface, looking for any sign of Kelvin waves, anything to support El Nino formation, or anything to impede storm development, like in the form of cold water and La Nina. And basically what we're seeing is a mixed bag. So what's the atmosphere above that think's going on? Well, right now the atmosphere looks like it thinks that we're in the active phase of the MJO, okay? When pressure is lower over Tahiti than over Darwin, the index goes negative. Today's value, minus 11.35. If you go down for this is about 14 days, I think, worth of data, and they've all been negative, and not super negative, but minus 11.35 isn't bad. Weak version of the active phase of the MJO, maybe. 30-day average is minus 6.49, and what's been the trend? Well, it's been falling, so that suggests the active phase of the MJO. The 90-day average, that's your El Nino indicator. If this is down at minus 15, you're in El Nino. If it's plus 10, we say you're in La Nina. We're at minus 2.64, and where have we been? I'm just scanning here. Basically unchanged for the past month, give or take half a point or something like that. So a dead neutral pattern in regards to the Southern Oscillation Index long term, but short term trending towards the active phase. In fact, let's go look at this graphed out. So here we go. Here's our downward spike of the active phase of the MJO. Now, it's not a major downward spike as compared to this one back in January 2019 where it just plummeted. Here's active phases of the MJO. This is right on about par for these other ones. Very weak active phase. The inactive phase, in fact, you can see the trend line here heading up. The inactive phases are stronger than the active phases, pushing the trend line up. We're almost dead neutral right now, just toggling around there. And again, no indication of El Nino. And if anything, we're trending towards La Nina, but we're not anywhere near that yet. We're just pretty much trending towards neutral for the moment. And then finally, the sea surface temperature trend forecast for the Nino 3.4 region, the official El Nino monitoring region. And this per the CFS model. This guy is the outlier. We've talked about this every week. Yeah, we've been hovering since 2019. For the most part, above average, but not really long enough or far enough to be considered El Nino. And the trend is, from here forward, nothing but downward, supposedly moving into a pretty deep La Nina as we get into the fall. That's why we've been spending so much energy looking at what's going on in the ocean, looking for any sort of a trend. I mean, this looks pretty horrible, but you look at all the data and it sort of says, well, we don't necessarily see it. In fact, you look at all the other models that are the El Nino monitors, none of them are suggesting this. This guy is an outlier, but still, we have some faith in the CFS model. It does a pretty good job, and we don't believe it's suggesting this trend for no reason. It senses something is going on, and certainly we've been in this warmer than normal pattern for a couple of years now. Yeah, we had a little dip last summer into negative territory, but that's like nothing. Probably the atmosphere is primed to swing the other direction, and that's what the CFS is cluing off of. We'll see, though. The next 2 to 3 months are kind of key. We're in the spring unpredictability barrier. The models have a really hard time knowing what's going on. It's not till you get into, let's say, mid to late May that you would really know for sure. But, I mean, if we're on this steady downward trajectory then and it doesn't hold itself by June 1st, then I would say we're probably going to head towards La Nina. But that's really what we're watching for now. It's not... We have no hope for some El Nino to come out of nowhere. It's just, are we going to fall into this hole? And how deep are we going to fall? And how long is it going to last? So that's kind of the thing we're looking at. So the immediate good news is, hey, there's a storm in the South Pacific, and we have had some southern hemiswell, and the models are suggesting there's more to come. So that's good. And the North Pacific, too. Yeah, some not storms, but gales and something that can produce some rideable surf. Looks likely, so there will be surf. The question is, can you get to the beach? And how bad are things going to get from the COVID situation such that at some point we would hope that they don't lock off access to all the beaches. So for now, get what you can, make the most of it. Long term, we're looking at least maybe not La Nina, but maybe a neutral pattern, but probably heading towards some flavor of La Nina, which suggests that as we get in later into summer, the storm machine might shut down. So get what you can now. If you have access to backcountry skiing and can do it and can be safe, go do that. Don't get too close to anybody. Go have some fun. Make the most of it. Try to keep your sanity. Try to keep your spirits up. And that's pretty much it for this week. If you like the video, give us a thumbs up. If you haven't subscribed, please subscribe. Just click the little button down there below and you get notifications every time we update this video. And since we don't have a whole lot else to do, we'll be doing it again next week. Same time, same channel. So thanks for watching. Everyone stay safe, take care of yourselves, and we'll see you next week. Thanks for watching.